In this video, we're going to look at an introduction to ionic bonding, particularly the formation of ions and why atoms, or how atoms, form ions. First off though, to bonding, and this is absolutely key to pretty much every part of bonding in chemistry. The question, why do atoms join together to form compounds? Why do they bond together? And the answer is here in this box, and it just has to be ingrained in your head if you're going to understand this. Atoms form bonds to other atoms because they want a full outer shell of electrons. So atoms want a full outer shell of electrons. Atoms are not happy until they have a full outer shell of electrons. And to do that, they will gain, lose, or share electrons to get that full outer shell. And that's how they end up joining together with other atoms, other elements. Because they do deals with them where some accept, some gain, some share, some lose. Okay, so question, why do atoms form bonds with other atoms? Answer, to get a full outer shell of electrons. Okay, so let's look at a nice simple way that atoms can get a full outer shell of electrons. This row here, I want you to complete this table. This row here is an example. So I've got an atom here, it's got 2 electrons on the first shell, 8 on the second shell, and 1, 2, 3, 4, 5, 6, 7 on the third shell. So it wants to fill its outer shell an extra electron. It wants 8 electrons to fill that outer shell. So it gains 1 electron. So we're now going to draw a diagram of this atom, but with a full outer shell. So it's now got its 8th electron down there. You can see it. There it is. There's the extra electron. There it is there. It wasn't there. Now, when an atom gains an electron, it's gaining an extra subatomic particle. Now, electrons are negatively charged. So before, it would have had 17 protons and 17 electrons, 17 positive charges in the nucleus, and 17 negative charges, these electrons around the outer shell. Now it's got an 18th electron, it's got an 18th negative charge. So what we have here is this atom. This was a chlorine atom, a chlorine-17 atom. It's still a chlorine-17 atom because the number of protons in the nucleus hasn't changed. But you can see there I've got a negative charge. Let's make it a bit bigger. So it's now a negative charge. So now what we've got, here we had an atom, now we have an ion. An ion is a charged atom, And why is it formed? It's formed because the atom wants a full outer shell of electrons. So let's look at this one here. Okay, I've got 2 on the first shell, okay, 8 on the second shell. So 2 and 8 is 10, and I've got 1 on the outer shell. That atom there is sodium. It's got a proton number of 11 and an atomic number 11. There's 11 positives in the nucleus, protons in the nucleus, and there are 11 electrons around the outside. Now you may think here this is now going to gain 7 electrons to fill its outer shell. And it could do that, I suppose, but it's not going to. It's not going to. There's another way it can get a full outer shell. There's another way. These shells, okay, sometimes they're called orbitals. Now the Earth orbits the Sun. Okay, the Earth goes around the Sun on an orbit. If the Earth were to cease to exist, then the orbit doesn't exist either. The orbit isn't a set of rails that like a train runs on. It's not an entity in itself. The orbit is just the path the Earth takes as it goes around the Sun. If the Earth ceased to exist, blows up, say, there's going to be no orbital left because the Earth won't exist. The orbit is just the path the Earth takes as it goes around the Sun. It's the same here. These electrons are going around the nucleus. They go around the nucleus on this orbital, these 8 electrons. Okay, but if these electrons don't exist, then this orbital doesn't exist. So this outer electron here, if sodium loses 1 electron, then that orbital, that shell, does not exist. So the shell beneath becomes the outer shell. So we're now going to draw this exactly the same over here, but we're going to draw it but with 1 less shell, and this shell here is now the outer shell, and it is full. So, to get a full outer shell, atoms can either gain electrons or lose electrons. And you may say, how do I know which is which? And the answer is whichever is less. So if it's got 3 electrons in the outer shell, it could lose 3 or gain 5. Answer, which is less? Losing 3. Okay, if it's got 5 electrons in the outer shell, is it going to gain 3 or lose 5? Well, 3 is less, it gains 3. Let's go through the other examples. First off, I need to put a charge here. So this is sodium 11, okay, and it's lost an electron. It's still sodium 11 because the atomic number hasn't changed because the number of protons in the nucleus hasn't changed. Well, let's quickly just draw the 11 protons up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, when it was an atom down here, okay, it had 11 electrons. 3, 4, 5, 6, 7, 8, 9, 10. And it had the 11th electron, didn't it? But we're just saying it's lost that electron. We're saying it's lost that electron. So what we now have, okay, is same 11 protons, but now we need 10 electrons. So we have this proton not balanced out by a negative charge. So the overall charge left on that is going to be now Na positive. Okay, so loses an electron, and it forms a positive ion. Brings me back to the one and only joke in chemistry. Two atoms walking down the street. One atom says to the other, I think I've lost an electron. And the first atom says, are you positive? Lost an atom, lost electrons, positively charged. I think I've lost an electron. Are you positive? Okay, that's about as funny as chemistry gets. Let's carry on with the rest of these. So this one here has got 6 electrons on the outer shell. So this one is going to lose 6 or gain 2. 2's less, gain 2 electrons. Gain 2 electrons. So now we're going to draw this, but with now this with these extra 2 electrons. Okay. There we go. Now, the smart ones amongst you will be saying to yourself, well, that looks the same as that. And it does. Okay, when everything in this period, you know, when many atoms get a full outer shell in this period of the periodic table, then they're going to have the same number of shells all filled up at the end. But does that make them the same? No, it doesn't, because the nucleus is different. So this was oxygen 8 atom. So this is going to be the oxide ion. Still oxygen 8, but now we've gained 2 electrons. So we're going to gain 2 negative charges. Okay, so that is different to that. I know it looks identical, but the nucleus is different. Okay. Right, this one here, it's got 2 electrons on the outer shell, so it's going to lose 2 electrons. Lose 2 or gain 6? Lose 2. 2 is less than 6. Now this atom so this is what's this? This is going to be magnesium, isn't it? Mg12. So this is period 3 of the periodic table. It's got 3 shells, 1, 2, 3. So this is actually the next period down, but it's still going to end up with the same electronic configuration as the oxygen in period 2. Okay, at the end, because it's lost 2 electrons from its outer shell. Does it make it the same, identical as this? Looks identical, the electronic configuration, but it is different because it is the magnesium ion. It's lost 2 electrons, so it's going to be 2 positive charges, like so. And you can do the last one on your own. A couple of quick questions on the next page. Okay, first one. What is the definition of an ion? An ion. An ion is a charged atom or group of atoms. So as soon as an element gains or loses its electrons, it becomes an ion because it is charged. Okay, so e.g. O2 minus. It could also be a group of atoms, for example, or the sulfate ion, for example, SO4. So you get the sulfur joined to 4 oxygens. When that happens, okay, that forms an ion as well, SO4 2 minus. The whole SO4 ion has got a 2 negative charge. So it can be just an element gaining or losing electrons, but you can have these complex negative ions. Okay, a couple of other definitions you've just got to know. Cation. A cation is a positively charged ion. Positively charged ion. These are always metal ions. A positively charged ion. Okay, e.g. magnesium ion, Mg2+. What is an anion? A negatively charged ion. So an ion is a charged atom or group of atoms. Okay, but positive ions have a different name. A cation and negative ions have a different name. An anion, a negatively charged ion. E.g., how about Cl minus? Or you could have these more complex cations, I don't know, like nitrate, NO3 minus. Okay, plenty of different examples. Now go back to the table on the last page and label all the ions as cations or anions. What trends can you notice? And the trend is the metals are going to be the cation. Sodium, cation. Okay, magnesium, cation. Oops, down here, magnesium, cation. Okay, and then the anions are the negatively charged ions. So the chloride ion, the anion. Metals are cations, non-metals are anions, and that is the trend. And you can fill that in at your leisure.